Around the globe, the use of prescription drugs is rising. In 2015, total expenditures worldwide on prescriptions passed the $1 trillion mark. The cost to healthcare systems is enormous. Half of all prescriptions now are handed out in the United States, where rates of prescription use are skyrocketing. Almost 70% of Americans take at least one prescription drug. But here's an interesting twist. In another study, over 75% of doctors say they have knowingly prescribed a placebo to a patient, a pretend drug that has no active ingredient and yet can often have as good an effect as the actual medication. How does that work? What are we finding out about the power of placebos? And what role could the placebo effect play in our healthcare system? Welcome to McGill Talks. I'm Jacquie Rourke. Joining us today are two researchers who have made groundbreaking discoveries related to prescription drugs and placebos. Jeff Mogil is a neuroscientist in the Department of Psychiatry at McGill. He's a recognized global authority on gender differences in pain and painkillers, and he is the Canada Research Chair in the genetics of pain. Amir Raz is the Canada Research Chair in the Cognitive Neuroscience of Attention at both the Department of Psychiatry at McGill University and the Jewish General Hospital. In a former life, Dr. Raz was a professional magician, and that has greatly informed his career and periodically entertains his students. Thank you both for joining us. I don't think we'll have any magic tricks today, but we'll have a lot of information. Prescription drugs, something that everybody knows a little bit about. The placebo effect, I think we've all heard of. But it plays a huge role in our healthcare system that maybe we're not aware of. Can we start, Amir, with you and just a definition of the placebo effect? What is it?
Well, the placebo effect is sort of a curious oddity where what you think actually influences the outcome of what you experience, either through physiology or through means that are largely psychological in nature. And it turns out that it's not always about the active ingredients in the drug that you take. It's about an active process that is going on that actually brings about a desired outcome.
And in your studies, you found that it's not just that people think they're feeling better. You can measure physiological changes after someone's taken a placebo that normally you would have seen with a medication?
That's right. So usually it starts with you thinking that you're getting better. That's usually the first step. It doesn't have to be, but it's usually the first step. And then you can, of course, make all kinds of measurements. Some of them are physiological, some of them are psychological, where you actually probe the well-being of people. You can do it through heart rate, through pupillary dilation, through changes of skin conductance, electrical conductance of the skin, through bowel movements, through all kinds of physiological indices. You can also do it by just asking people directly, how do you feel? And are you happier or do you have less pain and things of that nature? When you look at the umbrella of techniques that we have and the kind of inquiries that we make, we can actually demonstrate very clearly that placebos have a very compelling effect on people.
Give us an example in your studies just of someone taking a placebo and the effect that you saw.
So I think one of the major examples that placebos are known for are in the field of pain, where we would induce a particular kind of pain. It could be to your a particular part of your body. It could be to your arm, to your hand.
Like sticking the arm in ice water.
Ice water, or with something that would warm it up, or a little bit of lotion that would give some irritation or something of that nature. And we counter it with another lotion that is the antidote, or something that would actually make it go away. And we just forget to say that what we put on it is actually nothing. It's a moisturizer or something that is not supposed to do anything. But since in your mind what you have here is poison ivy, and this is the antidote to poison ivy, then it's supposed to go away. And sometimes that's enough for a lot of people in order to have a relief. For other people, it's not enough. And then the question is, what is so special about this process? Is it more unique to some people and less so for others? Is it something that is a function of age? Is it a function of intellect, of education? Does it have to do with a tendency to watch Star Trek or to be absorbed with books? So these are all questions that we're thinking about as researchers, and we're trying to understand. But the basic phenomena is there. I mean, we know that these things can happen, and they can happen in a very real way.
Interesting. Now, Jeff, you're a geneticist. You're an expert in genes. And one would think that the placebo effect is really just something in the mind, but you've been able to see that there's a role that genes play here, that there's a physical manifestation of the placebo effect. Tell us what you found.
Well, I mean, ultimately genes play a role in everything. The only question is to what extent. And for lots of phenomena like the placebo effect, people have done twin studies and found that approximately 50-50, genetics versus environments. And this is true for pain sensitivity as well. And so we've now gotten to a point where we have the technology to find these genes. This is actually, I wouldn't say it's easy, but it's becoming somewhat routine. That's the good news. The bad news is that there's turning out to be a lot more genes involved than we had hoped. And so, we are now finding maybe 10, 20, 50 of these things. The problem is that some people think that there might be hundreds or thousands of them to find. So we're definitely, we've started, we're on the road, but I think it's going to be a long time before we have any good explanation of what the genetic determinants of something like placebo effect are.
Maybe take us inside what a researcher does when it comes to trials and designing trials, and explain how the placebo effect is accounted for, that we already know there's going to be an effect.
Okay, I think the first thing to remind everyone is that before there are any trials of any type done in humans, there's a whole lot of work, 10, 15, 20 years of work that has to happen in cell lines and in animal models to try to provide evidence that a certain type of chemical compound, a drug, is going to affect, say, something like pain. Once that's been established, then usually a drug company will start the clinical trial process with human subjects. The early phases of that are simply to try to establish the safety of the drug in question. It's not going to kill anyone. And then they get to the phases where they try to prove that this drug is going to have an effect above and beyond placebo. So placebo effect is at the very heart of any drug ever getting approved. It has to be shown that the drug works better than placebo. And that, of course, is a tacit admission of the power of the placebo effect in the first place.
How effective is it? They give it, what, up to 50%? Or how does that work?
It depends. And of course, there's some reason to believe that the size of the placebo response is actually increasing over time. But of course, it depends on the type of trial you're doing and the type of drug and what that drug is for. And so generally speaking, placebo effects tend to be bigger in those things that have subjective responses. And
Give us an example.
Well, so pain is the classic example of that. There is no objective way of measuring pain. There's no scan that shows it. There's no a test for it. Pain levels are precisely what patients say they are, and fundamentally there's no way to improve on that. That's just the nature of the phenomenon itself. There are other things like depression or psychosis, where ultimately the call is being made either from the patient or from the doctor as to what the severity of that condition is. In situations like that, placebo effects tend to be very, very strong. That's not to say that they can't be shown for more objective things like, for example, wound healing, where the placebo effect has been shown as well. But they tend to be very large for subjective responses. Ultimately, in the simplest design of a clinical trial, you would have, a few hundred people, and they would be randomly assigned either to receive the drug or randomly assigned to receive placebo, which is going to be in a pill that looks exactly like the drug. No one knows who's getting what, and this is very important. The patients don't know whether they're getting the drug or the placebo, and their doctors don't know whether they're getting the drug or the placebo, and no one finds out until all the data has been collected. And then you simply see, okay, everyone's pain levels go down, both the placebo groups and the drug groups. But if the drug group's pain levels go down more, then this is an effective drug. Okay. And that's how the decision is made, whether to approve it or not.
Okay. So you recently had an interesting study where you found that this placebo effect and the difference is shrinking, but only in a certain place.
The difference between the drug and the placebo is shrinking over time, but that is because the placebo effect itself, or at least the placebo response, that is how much better people in the placebo group are getting in clinical trials. And this is in clinical trials of pain due to nerve damage that have been conducted over the last 20 years or so. We found, as people actually have been whispering about at meetings for a number of years now, that the size of this placebo group response has been increasing over time. The interesting part about our analysis, and the thing that people haven't been guessing, is that this is true only in trials that have been conducted in the United States. Everywhere else in the world, the size of the response of the placebo group has been stable over time. And so we found that that was quite interesting.
So why just in the States?
Well, that's a very good question, and there's actually a great amount of disagreement between myself and the other authors of the paper on that. It seems to me that there are a few options. One is that there's some difference over the years in how trials are being conducted in the United States versus elsewhere. Another difference is, another possibility is that there's a difference between who is enrolling in clinical trials in the United States versus the rest of the world.
What's the thinking there?
Well, it might be the case that different sorts of people are ending up being enrolled in clinical trials than used to be. One big difference over time is that all clinical trials used to be run in hospitals by academic labs. And this is no longer the case, especially in the United States. There's been a rise of what are known as contract research organizations, which are for-profit entities whose business model essentially is to recruit and run patients in clinical trials on behalf of the drug companies.
So these are highly motivated participants, I would guess. You see the ads everywhere. You go in the metro and there's any number of clinical trials I can sign up for if I want.
Indeed. And people suggest that that might lead to different patients with different characteristics, maybe patients that are more susceptible to the placebo effect. And the other possibility is that there's just something different about Americans now versus the past, and whatever shift has happened in Americans hasn't happened in the rest of the world. And one possibility there is that Americans now know all about the placebo effect, and they didn't in the past. And it's possible that exposure in the media to the concept of the placebo effect being real has actually increased over time, and possibly to a greater extent in the US than elsewhere.
Which is very odd because it's counterintuitive, but the power of suggestion and knowing about that, you'd think, well, if they know it's a placebo, the rates would go down, but in fact they seem to go up when they know it. Tell us about the power of suggestion and the role that the mind is playing in all this.
Well, I mean, in general, we are very symbolic thinkers. We anchor a lot of what we know and how we behave and how we react according to symbols, according to what we learned when we were young, according to all kinds of ideas that were bestowed upon us through folklore or through things that we read or we heard about. The internet, for example, plays a huge role in educating people today, something that was not available, not so many years ago. And as a result, people are exposed to all kinds of information that they were not exposed to before, although it existed, or certainly not with the same dose of information. And as a result, for example, in the United States, one of the things that Jeff mentioned, there's direct marketing of drugs, something that is not very common in other countries. As a result, when you turn on your television to watch the news, every few minutes you will see a particular ad for a drug, and as a result, you're a little bit more primed to that drug, and you might go and look up the ingredients for that drug and things like that.
And you're going to assume that it's going to help you?
Well, particularly if you see a very handsome-looking man there who is, as a result, has a very nice riding horses and doing all kinds of manly activities, and you identify with that and you'd like to be like that, then you say, well, that purple pill might do the same for me, and this is something that is influencing our behavior.
Advertising works. If it didn't work, the drug companies wouldn't pay what it costs to do it, and it probably, or at least possibly, works so well that after seeing direct-to-consumer advertising, which, as Dr. Raz said, is only available in 2 countries in the world, or only legal in 2 countries in the world, the United States and New Zealand, not only would you believe that that drug works, but you might actually start to believe that all drugs work, right? That is the power, potentially, of this advertising campaign.
Well, and some doctors are making it work. You did a study on doctors knowingly prescribing a placebo. So, and there's the ethical question involved, but yet it works. So I'm curious to think of where your research on all this could be taking us, given that do we need as many actual medications when maybe if we just are really good at suggesting it's going to work, we could save ourselves a lot of money. Where do you see that?
These are very complex questions because they're multifaceted, and you know, Jeff and I are sitting here as scientists, and you know, the role of scientists is to basically research and present the information. What we're talking about here now is beginning to be some kind of social trend, or how does it influence big pharma? How does it influence the insurance companies and so on? These are questions that go way above science and so on. As scientists, we certainly, appreciate and acknowledge how strong and how powerful placebos are. There's no question about that. We're fascinated by these phenomena. We're trying to understand the science of it by, systematically examining different conditions and different parameters that sort of play a role in these things. Clinicians are mostly interested in improving the health of their patients. I mean, this is what they're trying to do. And I think many of them over the years, although they don't learn much about it in medical school, they do learn through being in the trenches how important and how powerful placebos are, and they then need to navigate the professional world of doctors where giving placebos is actually bad form. It's something that is frowned upon. In Canada, there's slightly more latitude than in other places.
It's illegal in the U.S.
It's downright illegal in the U.S., and there's all kinds of ethical nuances there. In Canada, it's a little bit more of a gray zone, and then we have countries like Germany where it's downright legal, and in certain situations, doctors can actually prescribe placebos. But the idea is that we have not fully come to grips with the scientific information that is available. On the one hand, we know that these placebos can be very powerful and they can be leveraged to help people in all kinds of medical contexts. On the other hand, we haven't figured out a way that would be both judicious and ethical to do this in a way that both clinicians, researchers, and consumers would agree on.
The pharmaceutical companies must be completely against giving the placebo any more credibility.
They're unhappy. I mean, to them, this could be a potential nuisance, if not a very real one. But I think most pharma companies are very savvy about these things, and they take some kind of a practical, dogmatic approach to it where they're trying to, think about this.
There's a great irony here, because at the same time that it is illegal in some jurisdictions to explicitly prescribe placebo, and at the same time as the drug companies aren't very happy in a number of respects with the existence of this phenomenon, on the other hand, medical doctors and the pharmaceutical industry owe much of their success to the placebo effect, and they both know it. Doctors have been trained, whether explicitly or implicitly, to increase the placebo effect in their practice. They know and are taught that white coats make a bigger placebo effect, and bigger pills have bigger placebo effects than smaller pills, and more expensive pills have bigger placebo effects than less expensive pills. One could argue that much of the success of the medical profession since the beginning of time is the placebo effect.
Interesting. I want to ask you did that white coat, red coat study. Just tell us real quickly how that works.
It's basically continuing in the same line. So, red pills would make you a little bit more alert than compared to blue pills. So if you're trying to market a sleeping pill, a red color for a sleeping pill is probably not the best choice. But the same thing is true for the size of the pill, for the price. But this is not just for pills. This is also for wine. So if you sit down and I give you a bottle of wine that cost me $2,000, it's going to taste very different than if I give you something that I just got at the sack for for 12. It's human nature to worry about these parameters and to let these parameters actually shape and mold our physiological experience.
So what did you do with the red coat, white coat thing, though? How does that...
So there was this notion at some point, it was sort of a preliminary idea that when people conduct research, if they're researchers that would be wearing red coats to distinguish them from the actual clinical staff, from the doctors who would be wearing white coats. And this was just like a very nascent embryonic idea that some people were thinking about, and we immediately capitalized on that to do a very quick study and I think we actually used this studio in order to take people and with Photoshop or with some kind of a computerized version make the coats into red coats. Hello and welcome to our study. I'd like to give you a few instructions about what you should expect. Your blood pressure, your heart rate, and your pupillary dilation have been measured by one of our assistants. What's going to happen next is we're going to ask you to consider ingesting a pill. We're going to provide you this pill with a little bit of water for you to ingest. The pill may or may not contain a stimulant, such as caffeine. The effects of stimulants on the body are both physiological and psychological. And of course, it has a completely different effect on people who are taking the pills.
Of course, but one would think, so what was the effect?
The effect is that, when you take it from a white coder, this is real, genuine, and it's going to help you. And when you take it from a red coder, who knows what's going on? This is all random, and there's all kinds of, other background stories and hidden agendas that are going on.
If I might, this is incredibly important, and it makes the placebo effect in clinical trials so critical. In a clinical trial, the participants know that they might be on a drug and they might be on placebo, and furthermore, they know that that drug may or may not work. After all, it's only being trialed, right? But in the real world, you're being given a drug by your trusted doctor that your national regulatory authority has already approved as working. The placebo effect in the real world is huge. And this, of course, is what makes clinical trials so critical, because you're never going to know again whether that drug really works. Once it gets approved, it will always work. Right? Because it is the recipient of the largest possible placebo effect.
Can we trigger can we increase our placebo? Do we just have a little faith? I mean, can we make our own placebo effect work for us?
I think you can. I think you can in many ways. I think a lot of it depends also on the kind of habitat that, and the kind of environment, the kind of, social circle that you mingle in. I have 4 young kids, and they went through their growing pains of suspecting there's some monsters under the bed, until, of course, I got the monster spray, which is very difficult to get, and I'm not going to share the formula here, but a little bit of monster spray, a little bit of monster spray under the bed before you go to sleep, and the monsters cannot be there. And this is extremely effective, for some ages and for some, developmental milestones. It's probably going to be less effective, if I did it to Jeff. And the idea here is that you need to find ideas that would make sense, not just for the age and intellect and socioeconomic status of the group, but also for the culture and for the milieu in which you're set. So some placebos that would be good for let's say Quebecers are going to be would make less sense for Israelis, and vice versa. And this is it's very culturally dependent. There's certain universals.
So the snake salesman knew what he was doing.
Definitely. Most definitely, and that's
and they had real effects. If you bought into it, you really believed.
The interesting thing is that you don't even have to buy into it. I mean, it has real effects whether you buy into it or not, because by nature of being human, you are part of this particular trajectory. I mean, just being human makes you a part of this scheme. It is the psychology of being human.
Where would you like to see this research go, the mind-body connection? How powerful could it be, and could it be harnessed to lower our costs so we're taking less in terms of medication? What questions still need to be answered there? I'm guessing the gene thing plays a bit of a role.
Yeah, I mean, I think we all need to remember that as powerful as the placebo effect is, and it is in fact the most powerful phenomenon that biomedical science has ever discovered, but that being said, it still only works on a third of people, to a certain extent, some of the time. We would hope that biomedicine could do better than the placebo effect. And that, of course, is what biomedicine's all about. Okay, we all have the placebo effects, but maybe there are things that are even better. And there are things that are better. Antibiotics are better than placebo. Certain surgeries are better than placebo. In the field I'm in, unfortunately, pain, they're probably not all that much better than placebo. So there's a lot of room for improvements in many, many fields. And of course, that's what we're working towards. At the same time, I think we need to know how placebo works, not only so we can maximize it, and that'll be obviously useful in certain situations, but so we can better differentiate the placebo effect from, drug effects over and above the placebo effect that we're all hoping to get to.
Just quickly, when you said a third, does that mean 2/3 it never works, or it works for a third of people in the time in different circumstances?
This is probably a better question for Dr. Raz.
So this is very interesting, because I agree with everything Jeff is saying, and I would like to take it even further than that. When we study placebos, we definitely are trying to understand, what they're good for. So, for example, I wouldn't recommend placebos to lower cholesterol. I wouldn't recommend, placebos for treating strep infections or things like that. We have better treatments than placebo for that. And frankly, I think it's irresponsible to suggest something like that, just like I think it's irresponsible to suggest homeopathic medicine for malaria. But I don't think it's irresponsible to suggest homeopathic medicine for other things when I know fully well that homeopathy goes against the fabric of science. Because over there, the treatment is not done through the scientific bottom-up kind of approach that we are, so entrenched in, but it's done through a psychological top-down approach, which is largely, placebo effect. And I'm fine with that as a scientist. I'm completely fine with that. Doesn't mean that I endorse homeopathy. It just means that I understand something about placebo effects where this can.
It's really drawing on the placebo effect for its results.
That's right. In this particular case.
I agree with that, except for one thing. I really, as sort of an ethical matter, start to get upset when I see people making money off the placebo effect, which happens a lot. Homeopathy obviously is a prime example of that, but one could even be cynical and say that, well, medical doctors are making money off the placebo effect, pharmaceutical companies are making money off the placebo effect, and in my mind, the placebo effect should belong to everyone. I don't like the idea of it being monopolized.
Thank you both so much. Very, very interesting. We
Pleasure.
could continue, but good luck with your research. Thank you very much for joining us, Amir Raz, Jeff Mogil. And thank you for joining us. We hope you'll join us next time, McGill Talks.